Let's go over the mole-mole relationships. First thing is that the mole ratio, the definition is that it's a conversion factor that relates the amount, that relates the amounts in moles of any two substances in a chemical reaction. So we know how many moles of what we start with we have. We know how many moles we should get of what we're going to be creating. So a note here is that the numbers in a conversion factor come from the coefficients of the balanced chemical equation. So we also have to make sure that the chemical equation is balanced. If not, you have to balance it because you're going to need it. So if we're talking about something like an equation, let's do nitrogen plus hydrogen gives me ammonia, NH3. So I need to balance it. That's a 2, then that's a 3. So what this is saying is that a mole of N2, or nitrogen, reacts with 3 moles of hydrogen to create 2 moles of ammonia, NH3. And that's what we're going to be using for our mole ratios. 1 mole of N2, 3 moles of H2, 2 moles of NH3. So now let's go over what are the exact steps that you're going to take solving these problems. So step 1, make sure that the equation is balanced. Step 2, identify what information is given. Step 3, identify what you want. Step 4, identify what you know. And for this one's, what you know is the mole ratio. So what coefficient is in front of each compound or molecule or element. And the last one is just to set up your table and solve. And this table is this one where it's given, know, and want. So let's do 2 examples. So for the first one, let's do using the equation, the last one that was on the other slide. So it's N2 plus 3 H2 reduces or yields 2 NH3. Let's do how many moles of NH3 are produced if 4 moles of hydrogen react. So it's already balanced. 1, 3, 2. Next, identify what's given. 4 moles of hydrogen. So that's my given. Next, figure out what you want. I want moles of NH3. And what I know is going to be my mole ratios. So I need those coefficients. Okay. So let's go ahead and let's set it up. So my given was 4 moles of hydrogen. As soon as I write the unit at the top, write the unit at the bottom. Next, I want to know moles of NH3. So that's my want. And next, I just put in what I know. What do I know between moles of NH3 and moles of H2? I know that 3 moles of H2 produce 2 moles of NH3. So now all we got to do is multiply across, divide top and bottom. Mole of H2 is going to cancel with mole of H2. So we get 4 times 2 divided by 3. So that's 8 divided by 3. So for the answer here, we get 2.6666, but we're going to round it 2.67 unit at the end, mole of NH3. Oops, NH3. That's it. So we start with 4 moles of hydrogen, we end up with 2.67 moles of NH3. Let's do another one. We're going to use the same equation. N2 plus 3H2 gives 2NH3. For this one, we'll say how many moles of N2 must be used to create 2.5 moles of NH3. Okay. So we have the same equation. I'm going to just rewrite it since it got set to the front. So it was N2 plus 3H2 gives 2NH3. Okay, so that's the equation we're using. So from here, my given 2.5 moles of NH3. What I want, moles of N2. So I can go ahead and set it up. My givens will be the coefficients. So from this one, I'm given 2.5 moles of NH3. As soon as I write moles on top, write the same unit at the bottom, moles of NH3. And I want moles of N2. So for this one, we have 2 moles of NH3 with 1 mole of N2. So what we got to do is multiply across, divide top and bottom. Mole cancel with moles. So I'm left with 2.5 times 1 divided by 2. So 2.5 times 1 is 2.5 divided by 2. So for this one, the answer is going to be 1.25 a unit mole of N2. And that's it. So practice 4 questions. First, using the formula for water. How many moles of water are produced from 10 moles of H2? How many moles of H2 are produced from 10 moles of O2? Next one, you have the formula for rust or iron oxide. So for this one, how many moles of iron are used to make 10 moles of iron oxide, iron 3 oxide? And the last one, if 4 moles of O2 are used, how many moles of Fe do I need? So it's the same thing. You just got to do your mole ratios. Okay? So good luck.